So continuing on, question 3. For each of these, we're supposed to write a statement and a reason for the given information, and the hint is to sketch out stuff whenever we're not sure. So given R is between G and H, let's go ahead and sketch that out. G and H are on a line, and R is between G and H, so that means that R is also on the same line. Our statement is that GR, the distance from G to R, plus the distance from R to H, is equal to the distance from G to H. And the reason for this has to do with what it means to be between. And that definition of between is provided by the segment addition postulate. Okay, so the segment addition postulate tells us that if R is between G and H, then the measure of GR plus the measure of RH is equal to the measure of GH. Let's look at number 4. We are given that T is the midpoint of WS, line segment WS. So let's draw line segment WS, and T is its midpoint. Well, if T is the midpoint, then it divides WS into two congruent smaller line segments. So we've got the measure of WT equals the measure of TS. And that is by the definition of midpoint. Number 5, given that line segment WS bisects angle AWD. So let's draw and sketch out AWD. Remember, the vertex is in the middle, and we've got WS, which bisects AWD. So it's an angle bisector, right? So we already know the reason is going to be because of an angle bisector, and an angle bisector divides an angle into two smaller congruent angles. So we know that angle AWS, or we should say the measure of angle AWS, is equal to the measure of angle SWD. Okay, and that is by the definition of angle bisector. And finally, number 6, G, we're given that G is in the interior of angle MNP. Let's go ahead and draw that. Let's draw MNP. And G is in the interior, so it's somewhere around there. It doesn't say where in the interior, so when we join N to G, which we're going to do here, we don't know if this is an angle bisector. This could be larger, this angle on the top could be larger than the angle on the bottom, but we do know that the two smaller angles sum up to the larger angle, to the outside angle. Okay, and that's because of the angle addition postulate. Whoops, I should put that in the reason here. That's the reason is the angle addition postulate. And let's write out the statement. The statement would be that angle MNG plus angle GNP, or the measures of these more precisely, is equal to the measure of angle MNP. Let's take a look at problem number 7, where we're going to use some of these to solve a problem, some of these definitions. R is in the interior of angle ABC. So let's draw angle ABC, and then let's draw R in the interior, point R. And now we're talking about the measure of angle ABR. That would be this angle here. We're also talking about the measure of angle ABC. That would be the outside angle here. and we're also talking about the measure of angle RBC. That would be the lower angle over here. So let's see what each of these are. ABR, or this angle here, is equal to 4x plus 6 degrees. The entire outer angle, ABC, the entire outer angle there is equal to 3x plus 44 degrees. And the bottom angle, RBC, which is here, is equal to x plus 12 degrees. So by the angle addition postulate, we know that the measure of angle ABR plus the measure of angle RBC has got to be equal to the measure of angle ABC. And this is because of the angle addition postulate that we just used a few minutes ago. But now we can substitute in the polynomials that we know represent each of these angles. So ABR is 4x plus 6. The measure of angle RBC is x plus 12. And the measure of angle ABC is 3x plus 44. Okay, so let's go ahead and solve this problem. And let's also take use of some of the knowledge we know about proofs to see what justifies each of the steps as we go along and we solve this. Okay, so let's have our statement and reason. This way we can get some practice with algebraic proofs. So we've got 4x plus 6 plus x plus 12 equals 3x plus 44. I just kind of had to squeeze it in that one line, and that was because it's given. Okay, let's combine like terms, make this a little bit simpler to read. So the 4x plus the x becomes 5x, 6 and 12 becomes 18, equals 3x plus 44. Now we can fit it all on one line. This is by combining like terms. And now let's subtract 3x from both sides. So this is the subtraction property of equality, which gives us 2x plus 18 equals 44. Okay, and now we can use the subtraction property of equality once again, subtracting 18 from both sides, which gives us 2x equals 26. Okay, and the last thing to do would be to divide both sides by 2, and we get our answer x equals 13, which is by the division property of equality. Okay, so this would be the actual proof and justification of why x equals 13. But that wasn't exactly what we were asked to find. We need to find x, but we were actually in the problem asked to find the measure of angles RBC and ABC. So let's go back and do that. RBC is x plus 12. We said x is 13, so this is 13 plus 12, or 25 degrees. So that's the measure of angle RBC. The measure of angle ABC is 3 times 13 plus 44, which is 39 plus 44 degrees, which is going to be 83 degrees. Okay, and that's our answer. So the measure of angle ABC is 83 degrees. The measure of angle RBC is 25 degrees. And let's just check this, make sure that this works, because we should have ABR plus RBC equaling to ABC, and let's see if we get that. So if x is 13, the angle ABR is 4 times 13 plus 6, which is going to be 52 plus 6, which is 58. So is it true that 25 plus 58 is 83? Yes. Okay, so that checks out perfectly, and that gives us problem 7 is complete.